In this video, we're going to be looking at solving exponential equations using logs. And so this is going to be when the bases are not the same and they cannot be rewritten the same like we did in the previous video. And so to solve these types of exponential equations, we're going to solve them by taking the log of each side of the equation. So there's going to be 4 basic steps that we follow here. Step 1 is we're going to isolate the exponential. So we're going to isolate that exponential where the x is in the exponent. Our second step is we're going to take the log of both sides of the equation using the same base. Step 3, we're going to use the change of base formula for logarithms. So remember that was that log b of x is equal to log of x over log b. And then our last step is that we're going to solve the equation for x. So let's look at some examples. First one, I have 2 to the x is equal to 7. Here my exponential is already isolated, so I can move to step 2, and that is to take the log of both sides of the equation using the same base. So here my base is 2, so that means I'm going to take log base 2 of both sides. So I'm going to have log base 2 of 2 to the x. Here, I'm going to change colors so we can see our original equation. It's equal to log base 2 of 7. So why did I do that? Well, what we've learned before is when I do log base 2 of 2, that kind of essentially cancels out. And so I'm left with just x on this one side. And so I have that x is equal to log base 2 of 7. Now that I have x isolated, I need to figure out what log base 2 of 7 is equal to. So this is where our change of base formula comes in. And so using my change of base formula, I see that x is equal to log of 7 over log 2. And when I put that into Desmos, I get that x is approximately 2.81. Okay, let's look at another example. Number 2, I have 5 to the 2x is equal to 130. And so first step, isolate my exponential. This one's already isolated, so I can go ahead and move on to step 2, and that's to take the log of both sides with the same base. Here, my base is 5, where my exponent is with x, and so that means I'm going to take log base 5 of both sides. So I have log base 5 of 5 to the 2x is equal to log base 5 of 130. And so since I'm taking log base 5 of 5, that cancels out, and I'm left with 2x is equal to this log base 5 of 130. Now I need to use my change of base formula, so I have 2x is equal to log 130 divided by log of 5. And then when you put that into Desmos and rounding, you should get that 2x is equal to approximately 3.02. And then dividing both sides by 2, you get that x is approximately 1.51. Okay, let's look at another one. Here I have 7 to the 3x minus 24 is equal to 184. So this time my exponential isn't isolated. There's that minus 24 on that one side. So I need to go ahead and add 24 to the other side first. So adding 24 to both sides, I get 7 to the 3x is equal to 208. And now I need to take the log of both sides. So here my base is 7, so I'm going to take log base 7. 7 to the 3x is equal to log base 7 of 208. My logs base 7 of 7 cancels out, so I'm left with just that exponent. So I have 3x is equal to, and then use my change of base formula here, is log of 208 over log of 7. And then when you do that in your calculator or Desmos, you should get that is approximately 2.74. And then dividing both sides by 3, you should get that x is approximately 0.91. Okay, looking at number 4, I have 2 to the 5x plus 4 is equal to 7. And so this time I have a little bit more going on in the exponent, but that doesn't change what our first step is to go ahead and take the log on both sides. So this time I have log base 2. So I have log base 2 of 2 to the 5x plus 4 is equal to log base 2 of 7. My log base 2's cancel, and so I get just that exponent on the left-hand side, which is 5x plus 4, is equal to, use my change of base formula, this is going to be log of 7 over log of 2. And then when I use Desmos to figure out that right-hand side, I get that this is approximately equal to 2.81. And now I just need to go ahead and solve this. So I'm going to subtract 4 from both sides. And I get that 5x is equal to negative 1.19. And if I divide both sides by 5, I get that x is approximately negative 0.24. Okay, let's look at one last one. So here I have a little bit of a different problem. Now I have an e that's in there instead of these other numbers. So it's going to change what we do a little bit. But first step is going to be the same. I need to isolate the exponential. I have that 2 there. I have that minus 7. I want to first move what's being subtracted. So I'm going to add 7 to both sides. And I get 2e to the 2x is equal to 12. And then I get rid of that 2. So I'm going to divide both sides by 2. And I get e to the 2x is equal to 6. Okay, now I need to figure out how I get rid of that e. And so you could do log base e on both sides, because that's going to be the inverse. But remember, we don't use log base e. That special one that we used with e was natural logs. I'm actually going to be taking the natural log of both sides. So natural log of e to the 2x is equal to the natural log of 6. And so when I take the natural log and e, they cancel out. And so I'm left with 2x is equal to the natural log of 6. And then dividing both sides by 2, when you put into Desmos natural log of 6, divided by 2, you should get approximately 0.90.